And today, we got the invitation from David and from Henry to talk about Azure Synapse and Azure Databricks. And we couldn't think of a better way actually to run this session jointly between Microsoft and Databricks. And today we have James O'Keefe with us to talk about the Databricks component of the session today. I see some kind of known faces and some known names on the list, but those who don't know me, I am Fabio Braga. I'm a chief architect at Microsoft Australia. James, over to you to introduce yourself.
Yeah, thanks for that, Fabio. So James O'Keefe, so I'm an Azure Partner Solution Architect in ANZ. So I look after Azure Databricks. My focus is primarily on how do we integrate Azure Databricks with the rest of the Azure ecosystems.
So Tim, just to see how we're going to run this. So James and I, we talked about what would be the best way for us to talk about our respective components. And we found that for the sake of continuity, one's going to come after the other, right? So I'll start first talking about Synapse, what is Synapse and everything. Once I finish my part, James is going to come talk about Databricks. And then we get together at the end for a bit of a chit chat, discussions, questions, so we can answer jointly. Does that sound like a plan, Henry?
That sounds like an excellent plan to me.
Fantastic. So let's do this. Let's do this. So look, when you got the invitation for this session and they reach out to the guy at Databricks, so let's do this. It's really because we want to tell this story that Synapse and Databricks, it is a better together story, right? We're going to talk a little bit about the history of how everything started and how everything evolved. But it is clear the reason we are here talking today about these two technologies because there's some questions in your mind in terms of, hey, these services, they overlap a bit, or actually quite a bit. And we might be able to clarify, for example, when you should use one, when should you use the other. But more importantly, we're going to talk about some patterns here where it makes sense to have Databricks and Synapse as part of the same architecture, right? So let me start moving here in terms of what's the context of where this conversation is inserted, right? So look, we're having conversations with many different customers who are trying to enable their digital transformation, and they know that data is at the core of any efforts around digital transformation, right? So every time that you try to engage customers, provide new experiences to your customers, you improve the quality of your products and services, to optimize your operations, make them more efficient and cost-effective, to empower your employees, and to come up with new products and services, it all comes from insights that you get from your data, right? So in any digital transformation story, data is at the core of everything, right? And I want to start, before I jump into what is Synapse and everything, it is important that we talk about the context of where Synapse and Databricks are inserted, right? When you look at the Azure data platform as a whole, it is important to realize that the completeness of the platform, right? So this is going to make a difference later on when I explain exactly the roadmap for Synapse and the roadmap for Databricks. It is important for you to understand this picture because the entire data platform evolves together. So as new capabilities are added, let's say in Azure SQL database, it is possible that Azure Synapse is going to make use of that capability to enable some other workload scenarios, right? But this slide that you see on the screen is a great way to illustrate what sets Azure apart from a data and analytics capability because it covers the full spectrum of data workloads. We're talking about operational databases, right? And here talking about Azure SQL, MySQL, Postgres, Cosmos, MariaDB, right? Cosmos as NoSQL with the many different APIs for Mongo, Cassandra, managed instance for Cassandra API. All of these database offers that provides a way for you to modernize your applications as you move to Azure. All of these native capabilities in Azure. We talk about cloud native applications with the use of Cosmos DB, the introduction of AI in many of these applications with cognitive services, which are our machine learning models that Microsoft builds and train and expose them as APIs for developers to embed into applications, right? Cosmos and cognitive services is a great way to build kind of data-driven applications in Azure. In that analytics pillar in the middle, that's exactly where you're going to find Synapse, Databricks, Power BI, right? HT Insights, Data Lake, Stream Analytics, right? All of the analytics capabilities that we have available in Azure should create insights and provide that capability for big data handling with huge volumes of data, right? The ability to do AI with Azure ML, with custom AI with Azure ML, giving you the frameworks to monitor your experiments and see how your machine learning experiments are evolving, to capture the metrics around the quality of your models, right? And all of the compute power and the libraries that you might want to use for training purposes, and also the ability to host these models, of course, once they've been trained. We talked about cognitive services already. And finally, right, what the work that Microsoft is doing with Azure Purview around data governance, right? So when you look at the full set of capabilities, it's all there, right? So the full spectrum of data workloads available as native Azure services. And when you put that together with the rest of the Microsoft cloud capability, right? Just yesterday, I ran a session on Microsoft Reactor around the entire Microsoft cloud with Microsoft 365, Dynamics, the Power Platform, right? So when you put a common data model between these services, we are allowing the integration between these multiple cloud capabilities, which is unmatched in any other cloud provider, right? So when you look at the set of capabilities that is offered across Azure, Dynamics, Power Platform, Microsoft 365, as a way for companies to drive digital transformation, there is nothing out there in none of the other cloud providers that can match the entire set of capabilities, right? So some of the cloud providers may compete with one or two parts of it, but never with the full extent of the Microsoft cloud, right? These two slides are very, very important. Keep that in the back of your mind, because when you talk about that later, you understand exactly how Databricks and Synapse are positioned inside that block, which is the data platform as it moves together, right? Let's get going here. We have a lot to talk about today. Let's talk about the analytics continuum here, just for a second. This is a concept that we've been talking to our customers and explain that, just as I explained with the data platform, you need continuity for your data workloads, right? So you see at the bottom those seven squares, 7 blocks that says security and privacy, governance and compliance, availability, reliability, performance, scalability, skills and training, license and usage, and oversight and monitoring. All of these 7 blocks are enterprise scale kind of requirements that you cannot run away from. Any organization out there that is dealing with analytics workloads, they have to fulfill these 7 requirements, right? It is an ultimate requirements. We have legislation in place. We have industry requirements in place. We have security controls that are mandated in all of these environments. We have specific capabilities and functionality that mandate the fulfillment of these requirements. And depending on the platform that you choose, and this slide here is valid for any other cloud scale solution that you want to use, these 7 requirements may become easier or harder to meet, right? For example, if you decide to use a platform that there is not a lot of training available, that means your licensing and using and training skills might suffer a little bit, right? Or governance and compliance. So ones will be easier than others. But the point I'm trying to say here is, on top of these requirements, you have the variety of data that you have to deal with currently. You have long ago were the days that you only had kind of relational structured data, right? So what we have now is kind of a very wide range of data formats that come at different volumes and different speeds. Guys, I'm going to ask you to please mute as you join. Thank you. There's a bit of echo coming back, but that's good now. Thank you. So there's a whole different range of data formats that come in different shapes and different speeds that you have to deal with. And finally, the different workloads that you have to put on top of them, right? So this is the reality, right? This slide represents the reality of many organizations out there. They have these requirements, they have these many different data types, and they have the need to execute all of these different analytics workloads, right, on top of this structure, right? And as I suggest, of course, I'm going to start talking about Synapse as the first kind of star of the show today here, right? So Synapse sits at the core of this analytics continuum framework, if we put it that way, right? When you look at the capabilities between Synapse and Databricks, as we started saying today, there's a bit of an overlap between these capabilities. And let me start saying that overlap is good, right? Gap is bad, right? If there was a gap in our offer, that means that you don't have options. You have to try to find something else. Having overlap in Synapse between Synapse and Databricks, that's actually a good thing. It means that you have choices, right? And I think the whole conversation here today is where they overlap, you may need to make a choice, but where they complement each other, that's exactly the beauty of the better together story that we're gonna talk about today here, right? So let me start defining a bit of the structure of Synapse, right? So there's a lot of people that see Synapse as only as a SQL data warehouse engine, right? And that's a fair assumption because that's exactly how Synapse evolved. It used to be a standalone service called Azure SQL Data Warehouse, and that evolved to be a much bigger set of capabilities under the umbrella of Azure Synapse Analytics, right? So what used to be that SQL Data Warehouse engine is now just that one single component here inside Synapse, but Synapse is indeed a much larger set of capabilities, right? So let's talk about the analytics runtimes first here, and then I'll go and talk about the others. So for data warehousing workloads, we do have the SQL engine there, which is an MPP engine, and MPP, massively parallel processing, that's what I mean, right? For big data workloads, for big data warehouse workloads. And an MPP engine, you guys know how this works. It means that you have a cluster of server, multiple nodes, and whenever you submit a query to this cluster, your query is going to be distributed across these multiple nodes that will execute your query in parallel, each one of them being responsible for a subset of the data, instead of having in an SMP world, like have a single server kind of running the show, right? So when you look at the cloud data warehouse that we see in the market, all of them, right? All of them are MPP platforms, right? So Synapse, Snowflake, Redshift, Databricks, right? So any other cloud data warehouses out there, they are MPP platforms. And let me start saying something here, right? There is absolutely nothing wrong with hosting your warehouse if you have a small warehouse. By small warehouse, I mean, let's say smaller than 1 terabyte, let's say, right? So if you're a small to medium-sized organization that's running a data warehouse, it's very likely that you've been running on premises on a SQL server or an Oracle or whatever that is. And as you move to the cloud, you're trying to figure out, okay, which data warehouse engine should I use? There is absolutely nothing wrong with hosting your data warehouse in an SMP platform, right? You don't need an MPP platform for small data warehouses. Let's put it that way, right? There's every time that you go to an MPP platform, because it's a clustering and that's inherent of the nature of MPP platforms, you will end up with lower concurrency than compared to SMP. right? You end up with potentially a higher cost because you're actually running cluster with multiple compute nodes than you would be running with an SMP, right? So think about that for a second. And when you look at the completeness of the Azure data platform, we still have Azure SQL Database, Postgres, MySQL, MariaDB as relational database offers that can host your database for your small data warehouse with no problems of performance whatsoever, with no lack of capability, right? So from a SQL perspective, that's done. And then, right, we have the SQL Engine inside Synapse as an MPP as a cluster, and we also added a new SQL Engine with a serverless capability, right? So the SQL serverless in Synapse is a new engine that we introduced in Synapse that is able to query data from the data lake directly without the need to ingest data into tables. So I can run a select stuff from folder full of CSVs and push these results straight into a Power BI report, right? So if you have a specific use case that all you need is a Power BI model that needs to be refreshed, let's say a few times during the day from CSV files that land on your data lake, you don't need to have a data warehouse cluster up and running for that. All you have to do is to execute that serverless query, and you only pay for the amount of data that you're processing just to populate that Power BI model, for example. That's a very cost-effective way of doing analytics, right? Moving from SQL workloads, so data warehouse workloads will be there. Spark is the next kind of analytics runtime that is available in Synapse. And I believe that that's going to be most of the overlap we will be talking about between Synapse and Databricks will be in this space now, right? So guys, you guys know the history. The founders of Databricks, they founded Spark, they fixed all of the problems with Hadoop, and they came up with a much better engine that is the preferred big data engine in the market for big data workloads, right? All the Hadoop kind of workloads are kind of dying a little bit, getting off the stage, and we see an uptick in Spark as the preferred engine for big data workloads on top of Data Lake, right? Databricks made that as an open source project by the Apache Foundation, and Microsoft has implemented the open source Spark. That is Microsoft's own implementation of the open source Spark engine inside Synapse, right? And so if you're coming from a set of workloads that all you need, for example, is the capability of Spark to perform, let's say, some machine learning, some data frames, to apply some data engineering, data quality, data cleansing activities on top of data before you move to your data warehouse, for example, right? This Spark engine is capable of doing that, right? We're going to discuss later, for example, the Spark engine that sits on the Databricks side. Databricks, as James is going to explain, is by itself, again, a full set of capabilities as well, similar to Synapse, Spark being one of them, right? And of course, the agenda of how Spark is going to grow is very much, for example, attached to how Databricks is growing, right? So if you ask me today, who has the best Spark engine in the market, no questions asked, that's Databricks, right? If you ask me, for example, who has the best SQL capabilities, I would have a different answer for that one, right? I would say SQL will have kind of the full history of SQL that we have with workload management for data warehouses and big data. I would go that way. But look, these are both valid options. And finally, just to complement here, just recently we added another engine to the Synapse family, which is Data Explorer. You might know ADX, Azure Data Explorer, as an independent service, and the independent service will continue to exist on its own, no problems, but we are also bringing the capability of ADX inside Synapse to complement this picture of having a unified service for all different types of workloads. And Data Explorer here is an engine for observational analytics, right? If you guys use Azure and every time that you go to your Azure monitor and you run a custom query to query the logs of the telemetry that sits behind Azure, you are actually using the Data Explorer engine. So Data Explorer is the engine that powers the entire telemetry of the entire Azure cloud worldwide, the telemetry behind Xbox, the telemetry behind many of the Microsoft services, and many customers out there as well, right? So we have customers with running Data Explorer clusters with 1,000 nodes for very big workloads. Some tables with 40 trillion rows in one table, right? So again, different type of workload. It's for log analytics, telemetry, time series. That's the kind of workload that Data Explorer is going to cover. And when you put these capabilities together, we're talking about a single service. It's a single UI, a single provisioning a framework, a single permission model, fire rules, and everything, right? And the star of the show here, when we say that how Synapse integrates with the rest of the Azure platform, is one of the biggest differentiators that we have in the market for Synapse, right? So how Synapse integrates with Azure Purview and sends lineage information to Purview whenever you run an integration pipeline. Whenever the integration between Power BI and Synapse, so you can actually author reports inside Synapse, and vice versa as well. You can actually add some artifacts in Power BI. The integration between Synapse and Azure ML, where you have the ability to right-click a table and say enrich with machine learning, and you'll be able to invoke and bring some of the machine learning models that you've developed in Azure ML to be stored inside Synapse, right? So the integration between Synapse and the rest of the platform is one of the biggest differentiators of that. Over the next few slides, I'm not going to go deep into any specific features of any of the capabilities inside Azure SQL, inside Azure Spark or Data Explorer. I'm talking about capabilities that will help you with your decision around technology choices and to open your mind in terms of what's possible and what's available in a Synapse platform, right? So let's talk about a few things here that I think it was important for us to talk about today, right? On a SQL side, on the data warehousing side, right? So when you spin up a kind of a SQL cluster, one of our competitors, right? The guys with polar bear mascot, they have AutoScale, right? As a capability in their platform. But the AutoScale that we have in that platform is for concurrency only, right? It means that, okay, each cluster can take 8 connections, it can 8 concurrent queries, and as you start seeing queuing, new clusters of the same size will be spun up, right? But then you don't have any benefit of performance because each query will still be handled by each individual cluster in a round-robin fashion, right? If you want, for example, a segregation of workloads by another cluster, right? There's no way you can reuse your existing cluster to segregate workloads. It's actually buy more compute. That's how concurrency and workload isolation works. So in Synapse, one of the differentiators of the Synapse SQL platform is the ability to have in-cluster workload management, right? And that means when you have your cluster, right, however many nodes you want to have to help you with the performance, right? So the number of nodes is an indication of how much parallelism you apply to your data, which is going to be an outcome of faster queries, right? But when you have the full capacity of your cluster, you can, in that cluster, say, I want to reserve 40% of my capacity to my ETL jobs whenever they kick up, right? So whenever they start, I want 40% of my capacity, CPU and memory, to be done with my ETL workloads. And the remaining 60%, can keep serving queries. Whenever the ETL job is done, okay, cool. 100% is going to be allocated for queries. No problems whatsoever, right? So that means that you can prioritize your workloads to amount of resources inside the cluster and reutilize the capability of your cluster at the same time. And that's exactly the difference between workload isolation within the cluster. You also have the ability to establish workload importance inside your cluster. I'm not sure if you ever had a situation where the CEO wants to run a query, right? So we call them the CEO query. So it means that it's a very important query. It needs to return as fast as possible. We don't want to let the CEO kind of waiting, right? So we can attribute importance to workloads. So if the server is busy handling hundreds of requests and you start seeing queuing, when the CEO query comes and says, hey, this guy has a higher importance, this guy jumps the queue. He goes in front of the queue. So as soon as there's resources available to serve that queue, the CEO is not going to wait because he's going to jump the queue and be first in line. You don't need to have a separate cluster for the CEO just for that, right? You can have workload importance that way. And the ability to scale the cluster, of course, you can go up and down in the number of nodes with your cluster. So this set of capabilities in terms of in-cluster management with workload importance, workload classification, workload priority, and the ability to scale up and down, it's a differentiator, for example, that you won't have in the Polar Bear offer, right? Look, let's talk about a few other things here. Data protection in terms of security, all of the security that we find available inside SQL Server, as you guys kind of have been using for quite some time, are also available from within inside SQL. And that's an interesting point. And we're going to talk about the Lakehouse architecture in James' slides. And we know that, say, with the Delta Lakes, you can have Delta tables sitting on the data lake, and you can put some compute engine on top of the Delta Lake and query those tables to produce some insights and reports. That is awesome. But what if, for example, if we need dynamic data masking, row-level security, column-level encryption to protect some of the data, the most sensitive data? This is something, for example, that you can do really well inside an Azure SQL database with managed tables. Right? There's a myth that some people think that putting data inside Azure SQL pools as a managed table is going to cost more than leaving them out as Parquet files on the data lake. There is no difference whatsoever, right? In terms of the price of storage. So 1 terabyte of storage of data inside the SQL pool is the exact same cost of 1 terabyte of storage on the data lake, right? Because Azure SQL actually is backed by Azure Storage. It's the exact same price. There is no monetary gain in you putting your data, for example, not wanting to put your data in a SQL managed table and leave in the data lake, right? So that is something, for example, to consider. But all of these access controls that you see here, authentication, integration with Azure AD, threat protection, that's something that never kind of, not a lot of people pay attention to that. With the integration with SQL, with the rest of the security capabilities of Azure, can detect, for example, hey, is there anyone trying to do a SQL injection in my database? Is there anyone trying to access my database from a country that I'm not expecting any access to come from, right? So all of these signals that come as part of the Azure platform can help secure your environment. It's not just the security features inside the database itself, but what surrounds the database with threat protection, auditing, and vulnerability assessment. So, hey, I see that you have this table here has too many permissions and this PII data in this table, right? When you run your vulnerability scans, these things pop up, right? Let me talk a bit more about the democratization of Azure ML of machine learning inside SQL, right? So if you have been using SQL Server since SQL 2016, I think it was SQL 2016, we introduced the ability to host machine learning models, the trained model, the Onyx compatible binary file, the trained model, inside the database engine, right? So you can bring that model inside the database engine and host it in a table inside the database, and then you can score that model from within SQL. You can write a select statement and use the predict function, which is a T-SQL, a standard T-SQL statement, where you pass the model, you pass the input data set, which can be one of your tables, and then you have the execution, the scoring of machine learning models inside the SQL engine. You're not reaching out to anyone else. You're not going and calling APIs for anything. You're scoring from within the engine, right? Have a look at the documentation of the predict statement, because that's available not only in Azure SQL and SQL database, but it's also available from within Synapse SQL as well, right? So data scientists, they can train the model. They have all of the information about how to train the model. Once the model is trained, it becomes available to data analysts to run a SQL statement and produce and get the predictions from that trained model, right? So again, another differentiator of the platform there. We talked about the operational reporting just now with Synapse Link, right? So I gave you the example with Cosmos. Synapse Link is also available with Dataverse. I'm not sure if you heard of Dataverse, which is going to be my next slide. Dataverse is the data service that backs all of the Dynamics and Power Apps data, right? So applications. So if you are a Dynamics customer, or if you're building applications with Power Apps and you're using Dataverse, you can use the same principle here using Synapse to tap and reach out directly to the Dataverse storage layer, right? And get some insights from the operational capability, from the operational data sources for close to real-time operational reporting. And as I said, as we speak here, we are gearing up, we're getting things out of the oven for the launch of Synapse Link for SQL, right? So just be more patient. We are just 3 months away from the announcement. It's coming very, very, very soon, right? There you go, Synapse Link for Dataverse. As I said, right, it's Power Apps. That Dynamics family use Dataverse as a backend, and you can use Synapse as a way to tap into the Dataverse data for operational reporting, right? So the two capabilities. Again, reinforcing that differentiator of the integration, the strong integration between Synapse and the rest of the Microsoft cloud, right? So from within Synapse, the integration between Synapse and cognitive services, and Synapse and Azure ML, it allows you to right-click a table in Synapse and say, hey, I want to score a machine learning model, right? I want to enrich this data by calling some cognitive services and do a sentiment analysis, or to do a anomaly detection of my data set. Or even I want to call a custom machine learning model that was developed by my data scientists in Azure ML, right? So with a right click through the UI, that is going to give you a notebook experience, kind of notebook already filled with code that you can simply execute to get the data and the predictions already executed, right? That's a kind of a code-free experience that you generate from within the UI inside Synapse. Again, highlighting the importance of the integration between Synapse and the rest of the platform, right? Built-in cognitive services, as I just mentioned, I'll probably run a demo later on the studio. I'll show you some of these capabilities. But again, if you have cognitive service accounts in your environment, you can hook them up to your Synapse workspace environment, and you have the ability to do sentiment analysis and anomaly detection by leveraging the cognitive services models that Microsoft exposes APIs. More capabilities here. Data wrangling, right? So more and more you're gonna see very interesting developments over the next few months, where some of the most beloved Power BI experiences will become available and merged into Synapse. Let me put it that way, right? And the ability, for example, to use a Power Query, right? So if you guys have used Power BI before to apply some transformations to data sets, you know that you're dealing with Power Query. And Power Query is an activity inside Synapse pipelines, right? So with Synapse pipelines, which again, is another differentiator, right? So when you look at Synapse pipelines, it's a capability of the Synapse platform that is completely out of scope of other platforms out there, right? So the ability, for example, for you to reach out to your on-premises Oracle, SQL Server, whatever other database or files in on your file server on premises, and the ability to reach these servers and bring back data and apply some orchestration and enrichment along the way in a pipeline. That's something, for example, in other platforms, you'd have to go and hire or purchase a third-party ETL tool for that. They don't have this capability, right? Synapse pipelines a native capability and the ability to do low-code data wrangling with Power BI is a native component in there as well. Hybrid data integration, exactly as I just mentioned to you, the pipelines, right? So the capabilities that you have available from Data Factory, right? We brought these capabilities. Data Factory will continue to exist as an independent service, right? If you want to leverage Data Factory with any other platform, the capability is still there. The service is not going to go away. Data Factory and Synapse, they share now the same code base for the pipeline capability, for the data orchestration capability, right? So you have the same capability to use all of those almost 100 connectors now that we have available from pipelines that you can use as either a data source or a destination and perform your data orchestration and apply transformations along the way, right? It's something that is unique to the platform there, right? So again, it's a real-time operational analytics when we use these pipelines to kind of transform data along the way, right? Database templates, that's another one. I don't know if you guys remember, but a couple of years ago, Microsoft announced an acquisition of a company called ADRM. If you Google Microsoft acquires ADRM, I believe you're going to find that in a search. And ADRM was a company that had industry data models. They had a whole collection, a huge collection of data models that are specific for specific industries. Let's put it that way. They had a finance data model, they had a healthcare data model, retail data model, a manufacturing data model, an insurance data model, right? And with this acquisition that we made 2 years ago, we started this process of bringing these data models to the Synapse ecosystem. And this acquisition was released now as database templates. I'll show you in a second what they look like, but pretty much you can go to the Synapse Studio and say, hey, I want to create a new lake database from an existing template. And that's going to give you, okay, what industry do you want to start with? Oh, I want a retail database. And that's going to give you, okay, here are the most common entities for any retail workload: customers, orders, products, suppliers, right? They're going to be all there and say, yeah, cool, these are the tables that I want. Generate my model. By the way, before you generate the model, you have the option to customize, add some extra columns if you want, add new tables if you want from scratch. When you say generate model, you can choose, okay, generate model to these as files in my data lake or as tables in my data warehouse. And you can even map your source systems to your models to automatically generate the pipelines that will ingest data into these tables that you've just created. It is a fantastic way to accelerate the time to insight, right? So database templates, I'll give you a view in a second what they look like. Right. Power BI offering. As I mentioned, the integration between Power BI and Synapse will only grow, right? Will only grow from here. So the current capability, I'll give you a rundown in a second, is you can actually visualize reports and you can author reports Power BI reports from within the Synapse interface. You don't need to leave Synapse for that. So let's say you've just run a pipeline to ingest data into your data lake or a data warehouse, and you want to see exactly what's the impact that this run has had in your reports. You can bring up the report straight away from within Synapse and you see the impact of your pipeline, and that's how you gain productivity, right? The further integration between Synapse and Power BI is, for example, from within Power BI, you can trigger the optimization settings that will automatically create, for example, some materialized views in Synapse to speed up the performance of Power BI reports that hit the data warehouse, right? And thus minimizing the need for concurrency because it's going to be a materialized view that will be in cache, right? And you should expect to see even more and more integrations between Power BI and Synapse coming in the next few months. Right now, for example, internally at Microsoft, we are trialing a capability in Power BI and Synapse. It's an awesome one. I don't know if Min is in the session today, but he's seen. You guys, I'm not sure if you guys know Min, right? He's a very active member of the analytics community. He's very active on Twitter. He likes to talk, and he's been a kind of a very active voice around the use of analytics engines, and he's seen some of these capabilities, and he wrote there. He was sort of, I'm impressed about what's about to come in the integration between Power BI and the rest of the data platform. So there's more to come in that space for sure, right? The Data Explorer engine, as I mentioned before, it is a specialized engine for telemetry data, for time series information, for log analytics, right? So if you want a comparison, for example, okay, what kind of workloads I can put in Data Explorer? If you look at, for example, competition and what's happening out there, services like Splunk, services like Elasticsearch, services like, what else is out there that can do this? Well, let's pick these two, right? Elasticsearch and Splunk, that they collect all the telemetry, for example, and Elasticsearch for kind of big data search capabilities. These, for example, are workloads that you can also execute from within the Data Explorer engine, right? All the telemetry that, as I said, all the telemetry that runs in Azure is inside Data Explorer as well. I'll run a demo as well if we have enough time for all of this. And finally, automatic aggregations, that's the integration that I just mentioned between Power BI and Synapse, right? So automatically create materialized views. Power BI will automatically aggregate data and push that into cache. The integration between Synapse and Purview, right? You see in the GIF on the screen that once you hook up your Synapse workspace with your Purview account, the data catalog in Purview becomes available to be browsed from within Synapse. So imagine that you're a data engineer creating a pipeline and it finds, hey, I need to find customer data sets in my organization. Where are they? Where are the customer tables? So from within Synapse, you can do a search for customer. You find all of the possible data sets for customer, right? Wherever they are, data lake, databases, whatever that is. And from there, you can automatically create a linked services and a data set to draw a pipeline from there. And you can see there, you can browse the lineage of these data sets to make sure that am I getting the data from the right point in the lineage, just to make sure that I have the completeness of data sets here. So again, these are all capabilities in Purview, but when they put them together with Synapse, you have this ability to browse the catalog, create artifacts without leaving the Purview interface. Oh, sorry, the Synapse interface. And just likewise, if you run Synapse pipelines, Synapse can also push lineage information into Purview. Whenever you load, for example, files into your data lake, and then you apply some transformations and load into your database or warehouse, and all the way into Power BI, you see that, okay, this file came to the data lake, and then it was transformed, went to the database, it went to a Power BI data set, to a Power BI report, and finally to a dashboard. You can see the full lineage inside Purview. Right. And here it is, right? So we're talking about the integration between Purview and Power BI. You see on the lineage information that you see right now, you can see that for the data from many different data sources flowing all the way into Power BI, right? So again, this is not so much kind of a Synapse capability, but of course, if you have Synapse as a data source, that's going to show up in the lineage as well, right? Okay, there you go. We've been asking for Synapse link for SQL, as I mentioned, Q2 2022, right? So that means end of this financial year. That's the Q2 of the calendar year. Yeah, exactly. You see the announcement of Synapse link for SQL, but it's no secret. We kind of announced that in the last Ignite, saying that we were working on it. In terms of Spark Engine, Spark 3.2 public preview in Q1, so I think it's going to be released over the next few weeks, and that brings a whole bunch of advancements in the Spark Engine. I think currently in Synapse we're running 3.1, right? Databricks, of course, has been running 3.2, I guess, for quite some time now, but 3.2 is coming to Synapse, and all of these improvements in the Spark Engine will be there as well, right? And of course, with the Spark 3.2, you get the same kind of Delta Lake performance enhancements that was part of the engine with Optimize and Z-Order and everything there. Just being cautious of time here, I'm trying to cover as much content as possible. Synapse cache enhancements, we're gonna actually cache files to speed up your queries instead of actually reading all the time from the data lake account. That's going to improve the performance. And finally, that's it. I got you the end of my session there. There is a part of the session which is we can call about roadmap later on in terms of what capabilities are coming. You just saw some of these things come in the next few months, but the message that I wanted to land here with Synapse is, look, you just saw how Synapse is positioned in terms of different compute engines, different types of workloads, and how well Synapse integrates with the Azure Data Platform, right? And that's one thing to keep in mind in terms of, okay, so whenever you need information about your decision in terms of what feature and what capability to use, at least you know exactly what these features and differentiators are. But again, look, the story with between Synapse and Databricks, it's a good one. James is going to cover now the Databricks definitions and how Databricks differentiates itself from the rest of the platforms. And we're going to talk together about the patterns where Databricks and Synapse show up in the same architecture. James, over to you.
Cool. Thanks for that, Fabio. That was awesome. Fantastic. All right, so let's just move straight on. So hopefully you can see my Lakehouse slide there. So just a little bit first about Databricks for those that may not know. So Databricks was started, as Fabio said, by the creators of Apache Spark quite a number of years ago. This is a little bit of a dated slide. I think we've got over 7,000 customers across the globe, lots of partners as well. And we're responsible for, or at least kicked off a number of different technologies. Obviously, Apache Spark's one of them, but also Delta Lake, which we're going to talk about quite a bit here, as well as MLflow, which is a machine learning model sort of orchestration framework. We'll talk a little bit about that, but primarily we're going to sort of be talking about Delta Lake, and a lot of discussion about the Lakehouse, which is this new pattern that's got a lot of attention. And we'll have a look at some architectures that support the Lakehouse. And as Fabio said, this is very much a better together story, and we'll see how all of the services within Azure actually leverage and support the Lakehouse pattern. Okay, so first of all, let's just sort of set a bit of a scene here, and these should be pretty familiar. I think Fabio covered a lot of this very well in the earlier on. His probably slightly flashier slides and icons than mine, but so organizations are dealing with a very, very complicated data landscape at the moment, right? So if we look at the bottom, they're dealing with all different types of data, everything from semi-structured, unstructured through to fully structured. all different, you know, sizes, big, small, and velocities as well, right? So they're dealing with this varied data landscape, right? And they want to, you know, they want to land it somewhere. They want to put it somewhere, and they want to land it in the most cost-effective place. And so they'll put it in a storage layer, typically as raw data. But then they've got these objectives that they want to perform, these business objectives, you know, data engineering and streaming. They want to do data science and machine learning, and they want to do more and more SQL analytics and business intelligence. But to really effectively achieve those goals and do those kind of things, you know, you really need to be, you know, leveraging curated data, right? You know, you can do it with a bit of raw data, but, you know, the old saying, you know, garbage in, garbage out. You know, if you want really high quality results and quality models and analytics, you know, you want to be dealing with curated data. So that was that's sort of the goal. That's where organizations want to be. But the reality is that, you know, organizations are really struggling because they've got silos. And they've got, within each of the silos, they've got, you know, personas that are dealing with all different types of tools, and it's complicated. You know, this little example here, you know, we've got data warehousing, so different technologies there and different patterns around data warehousing, data engineering and streaming. You know, data engineers are typically in that space. Again, they're using a whole lot of different technologies. And then finally, you've got data science and ML, and they've got yet another set of technologies, you know, everything from Jupyter notebooks to specialized data science applications, you know, MATLAB, all sorts of things. So they're all using different tools, and they're all consuming the data in different ways. But it's complicated, particularly for those that need to try and manage all of this. It's really difficult to manage the data estate. So that's the problem that they're dealing with, and the fact that they're all using different tools also, you know, slows down innovation and productivity. So now we're going to start talking about the lakehouse pattern, which we believe is a solution for that complexity and that inertia that is you know, baked in through that complexity. Okay, so first of all, the lakehouse. Let's, you know, a little bit of confusion about what the lakehouse is, but let's really sort of boil it down to its simplest term. The lakehouse really is a very simple pattern. It's about decoupling compute from storage, bringing the right type of compute to the storage. And, you know, in the past, that's been a little bit difficult because, you know, you've had the different compute engines were utilizing, you know, their own or different storage, and that led to you know, duplicate data sets and inefficiencies. So Lakehouse, as I said, at its core is all about bringing the right type of compute to the data. So again, we have those different sources of data, you know, the different velocities and sizes. And so the idea being, if we want to satisfy those business objectives that we saw earlier, we need to have that data in a curated data lake. And that's what the Lakehouse pattern is all about, having a curated data lake that has a number of features. So it needs to be able to handle all of those different sizes and velocities. It should be an open format, right? So you know, customers shouldn't feel like they're being locked into a proprietary format. It needs to be supported across, you know, as many of the Azure data services as possible. I'm a little bit biased. I'm the Azure Databricks guy, so I'm all about Azure. And I will say that, you know, the Azure Databricks is the premier Databricks. You know, it's the Azure Databricks is the most integrated Databricks we have, and we'll look at some of the integrations in a little bit of detail. But just while we're on this slide, I just want to sort of talk about some of the foundational integrations that are there. So obviously there's the authentication is integrated, the billing is integrated, the log analytics, for example, you know, you use Azure Log Analytics to send, you know, you compute logs and telemetry logs. So it's very tightly integrated into the Azure platform. You probably heard, or those that have heard of Azure Databricks have probably heard that it is a first-party service, and in fact, you know, it was co-developed between Azure engineers and Databricks engineers, and so it's a really tightly integrated Azure service. So we're talking about the foundation. So we've got that integration there. Now the next is all about data management. And so what makes that curated data lake, right? So you need things like ACID transactions, you need data versioning, you need audit history. So you need all of these capabilities built in to that lake house to create that curated data so that you can feed the data into those applications. And the objective here is being that single source of truth. And so, we've got a number of Azure services there that all can leverage that Delta Lake powered lakehouse. So Databricks, of course, and I'll talk a little bit about some of the special source that's in Azure Databricks, but Azure Synapse as well. So Azure Synapse can read lakehouse. So directly, the SQL pools can read directly out of the lakehouse. Purview integration as well. So you can use Purview to analyze and manage the metastore, the Hive metastore that's at the center of Azure Databricks. It can look down and audit and query the underlying files that are also down in the lakehouse, the actual Delta Lake files. There's also support for the PyApache Atlas. Azure Purview supports Atlas under the hood, and so using libraries like Python libraries, you can directly ingest data and lineage directly into Purview from Azure Databricks. So a lot of integration there. And there's another technology called Unity Catalog that's in private preview that's all about tracking and building and managing access and lineage within Databricks, but it will also integrate with that, with Azure Purview as well. So Azure Machine Learning, I'll talk a little bit more about that when we get to machine learning, but again, tight integration there via the MLflow technology. And also Power BI, and Power BI can be used in a number of different ways. It can either talk to a Databricks cluster to get access to the data. It can also talk through a SQL endpoint. And of course, you can use Power BI in conjunction with Azure Synapse and the Azure Synapse integration with the Lakehouse and Databricks to also, bring your data up into Power BI so that you can create your dashboards and reports. Okay, so just having a look at some of the components and use cases, we'll dive down into a little bit more detail of each of these, but just at a high level, again, familiar pattern. We have our curated data. This is our lakehouse. We have within Databricks, we have a Delta engine. So this is a unique capability within Azure Databricks that allows it to really speed up queries when it's analyzing data in the Delta Lake format. So everything from skipping to intelligent uses of caching. So a really high performance engine when it's querying Delta format data. And that engine, supports those three use cases that we have already discussed. So the data engineering and streaming, ML and data science, and SQL analytics and business intelligence. So it's a really simple one architecture to support all of those use cases. Some other things that Databricks has just from a usage perspective, it's a collaborative environment as well. So, we saw that complicated slide with all of the sort of spaghetti lines of different tools and whatnot. One tool for your data engineers and your data scientists to use and collaborate with. So, just having a look at the proven architecture on Azure Databricks. Now we're going to, in each of the three different areas, we're going to sort of focus on some specific aspects of this architecture. But again, I just want to point out some important points here just around some of the integration. We have that curated lakehouse at the center. You'll see this concept of this bronze, silver, gold. This is this medallion data sort of quality architecture, if you like, that we talk about. These are just completely arbitrary. You can have as many different labels, but the idea being that you bring data in from the left-hand side. This is maybe your raw data. You do some form of ETL or cleansing of it, maybe stripping out certain columns that that are of no benefit, for example, and then you may do further ETL operations to you know, create that gold layer. So that might be the one that you use for your business aggregates, for example, either feeding directly into Synapse, or you know, via a SQL endpoint. You know, so Power BI connecting through a SQL endpoint, reading those gold aggregates out of the lakehouse. So, you know, as Fabio mentioned, you know, the beauty of the platform is that there's a lot of choice. There's a few, you know, different ways of doing them, achieving your goal, depending on, you know, what you're trying to do. So so lots of great choice there. We'll talk a little bit more about the data science as we move on as well, but just something just around batch ingestion. So, you know, a lot of support for Synapse as well as ADF, both pipeline support as well as the mapping data flows support. So, you know, Delta support is tightly baked into ADF as well as the pipeline management system directly within Synapse. Now am I going for time? Okay, so let's now have a look at some lakehouse patterns. So this first one, data engineering and streaming. Again, there's that familiar lakehouse at the center. We've got Databricks sitting over the top, you know, utilizing that Delta engine. And, you know, there's a number of features that support data engineering. So, you know, we have autoloader. So this is the ability to basically specify, you know, a container, an ADLS container, and any data that gets dropped in there, we'll just pick up and process it and you know, turn that into a Delta Lake format. We also have Delta Live Tables, which is an ability to have basically a live ETL process. So as data comes in, it's processed via a Delta Live Table job. And you know, the output is provided for you know, either downstream processing or you know, the next stage of the job. There's also unified batch and streaming. So, you know, one of the features, really cool features about Delta Lake is its ability to support simultaneous batch and streaming. So, you know, again, that mantra about, you know, let's try and have, you know, all of our data in one place and satisfy all of our use cases with that, you know, that one lakehouse pattern. You know, the unified batch and streaming means that, you know, we don't have to create snapshots of our data, our streaming data, if we wanted to do batch operations on it. So, you know, a great feature of Delta Lake. And again, you know, single architecture that we've spoken about a bit, you know, open standards. So Delta Lake has been, you know, donated to the open source community. So, you know, fully open source. We do, as I said, we do have our special source. Our Azure Databricks special source is our ability to query and manipulate that data. It doesn't change the format at all, so there's full portability there. But when you use, you know, Azure Databricks, you know, we've got, you know, quite a number of features that allow us to really process that Delta format quickly and efficiently. Built-in support for CDC as well, and you know, single compute and storage layer. So a very, very simple architecture. Okay, let me just let this one build out in the interest of time. So that was a bit of a high level. Here's a little bit lower level and some of the features that that support that. Again, we can see our two different sources of data coming in. So it could be batch data. We could be using ADF, for example, to reach into on-prem data sources or databases. And you know, using ADF to call Databricks jobs, you know, based on extracting that data. We could be using other streaming services in Azure, like IoT Hub or, you know, Azure Event Hub. So full support for those streaming engines directly within Azure Databricks using Spark structured streaming. Delta ingestion, I already mentioned the autoloader. So copy into. So this is a great feature. This is, you know, a feature that supports high-speed ingesting into Synapse SQL DW. So we support Polybase, but we also have this you know, this T-SQL copy into support, which can really speed up bulk inserts into Synapse from Databricks. We have the optimized Spark engine. That's that optimized Spark engine, part of the you know, well, the Delta engine and the optimized Spark engine are synonymous. That high-speed engine that is so good at processing the Delta Lake format. And Synapse pipelines and ADF, I've already mentioned the tight integration there. Integration with all the different storage layers as well. So as part of that one authentication mechanism, we can either use table ACLs, or we can offload the access to the underlying storage using what's known as pass-through. So we can you can set up ACLs on your ADLS containers and objects, and we will honor the ACLs that are governing access to that data. Just a little bit more up in the Delta engine. So again, optimized Spark. We have the job scheduler. A lot of work going in the job scheduler at the moment. It's a fairly simple, a bit like a glorified cron. If any of you come from Unix or Linux kind of background. For more of the enterprise kind of workloads, ADF is what we mostly see. Use ADF to actually call the Databricks notebooks and jobs. Tight integration there. Support for multiple languages, so Python, SQL, Scala, and R are fully supported in the notebooks, as well as ephemeral clusters. So, we have a number of different cluster sort of modes, if you like, everything from just a single node cluster through to high concurrency clusters that are useful when, a whole lot of people, want to use the cluster at the same time. Or standard clusters, which are usually the most common. These are the ones that are usually used for a single user or a large ETL process. And again, integration, tight integration, Power BI tight integration, including pass-through authentication from Power BI down into Databricks. Directly to the regular clusters, as well as the SQL endpoints. Synapse, mentioned the copy into support. We've also talked about the support. Synapse SQL pools can read, and access Delta Lake storage as well. We have connectors for Cosmos DB and Azure SQL as well. So from Databricks you can inject data directly into a Cosmos DB database. So tight integration and support for all of the services within Azure. Right, let's moving on now. Machine learning. Again, a lot of commonality here. We have that curated data lake. That's our lake house. Some of the features that we have, so we have a built-in feature store that can utilize Delta Lake. There's the ML runtime that's built on the Delta engine. So what the ML runtimes are is we pre-bake into the image that is used to provision a cluster node all of the popular machine learning frameworks. So your TensorFlows and your scikit-learns and all of the different ones out there, PyTorch. Of course, you can bring your own as well. So you can load your own libraries in as well. But to help you get moving really quickly, we've got ML runtimes that are all set to go, including support for GPUs as well. So for deep neural networks, deep learning that typically benefit from GPUs, we support I think it's the NV series in Azure that have the GPUs. So all of this is run in the Databricks environment, and the ML ops all managed by MLflow. So you can do all of your data prep and your feature engineering. You can register the models in MLflow. You can track them. Full versioning support, as well as both serving directly within Databricks, or serving into Azure Machine Learning. So MLflow supports both Kubernetes and ACI types of containers. So you can train your model, and then if you want to provision a REST endpoint, for example, use MLflow or programmatically to push that into AML for serving. Okay, so let me build this one out just in the interest of time. So just going a little bit lower here, some of this, again, consistency. You've seen some of this before. There's that curated data lake. That's our lakehouse pattern. We've got our medallion, data quality hierarchy there. We're doing our data prep. We're using the high performance Delta engine. We've got support for those different languages: Python, Scala, R, and SQL. Koala's support as well, which is essentially the Pandas API, but using Spark data frames. We are using MLflow to manage and track not only our models and how we're developing our models, but all of the hyperparameters that are going into the models, all of the metrics that get generated when we run training runs, as well as other artifacts as well. And then finally, model serving that we've talked about. So both directly within the platform as a REST endpoint, or using MLflow integration with AML to deploy the model into AKS or ACI. And Databricks SQL under the hood. So we released, I was in preview for about a year, we released this new feature called Databricks SQL. Some of you may have heard it originally called SQL Analytics. So really, this is Databricks SQL is really a platform to make SQL analysts feel at home when they're working in the Databricks environment. We have a notebooking environment that is great for programmers, and while it supports SQL, a lot of traditional SQL analysts didn't necessarily come from a procedural programming background, and so Databricks SQL is the ability to run ad hoc queries over the lakehouse and generate reports and dashboards. The endpoints that it creates, so the actual compute under the hood that supports that, you can also connect to directly from Power BI, as well as a number of other third-party products as well. So it supports not only obviously the Delta engine, but Photon, which we now support in our regular clusters that are available for data engineering and data science. But Photon originally was developed for SQL Analytics, and this is a new engine at the core of Spark that was written in C++. So as opposed to being written in Python, being written in Scala and Java like the original engine was, this was written in C++, so is blazingly fast and has a whole lot of other performance enhancements as well. It's particularly effective when you're doing lots of merge or group by kind of operations. Okay, and then let me just build this one out. Okay, and so just going a little bit deeper down into SQL Analytics or Databricks SQL. Again, that Delta engine, you've got the query editor, so it's a you can write your SQL code and you get IntelliSense and completion and all of that kind of thing. You can build a catalog of your queries, you can create dashboards, you can schedule the dashboards to run, you can set up alerts. There's connectors as well, ODBC and JDBC connectors. Obviously Power BI that we've mentioned already can connect directly using both the direct query, or can use batch mode. And there's a history and full security baked in as well. So, this slide is probably a little bit showing its age. Photon in brackets, this was when Photon was only available in Databricks SQL, but now available in the data engineering and data science clusters as well. Okay, so just summing up, these are really the design goals and the why we think this lakehouse pattern is so powerful is it's simple, right? So all of your data, a simple architecture with all of your data in one place, proven architectural patterns that are simple. It's really simple to get going to build your lakehouse. It's particularly simple in Azure Databricks. You click on an icon and you create your Azure Databricks environment. It used to be about 2 pages. We've bolstered a lot of the security features as well. So things like private link, which is coming, support for VNet injection and other high security kind of architectures that may be required, but still really simple to get going. All based on open source standards. So everything that that we've developed everything from Azure Apache Spark, I should say, ML Flow, Delta Lake, koalas, all donated to the open source community. We've got a fantastic environment for you to develop your, your ETL pipelines, or you can bring, your favorite IDE as well. We also support very much an API approach. So, we have tight support for Azure Devops, for example, and we see a lot of this where, customers are wanting to deploy an Azure workspace and want to deploy clusters and then use ADF to kick off jobs. So, full API support. And it's a collaborative environment as well. So, your data engineers and data scientists can be working off the same notebook, at the same time. And, in a similar way to, if you use Excel or Word and there's multiple people working on it, you see the little icon in the top right-hand corner, same kind of experience. Okay, so I think that's it. Well, this is just a summary. This is a slide that we've seen before. I just want to, further emphasize again what Fabio mentioned, around the tight integration and how Azure Databricks it's an Azure service, and it's unique in that it's got really tight integration with the rest of the Azure ecosystem. The Lakehouse is all about having your data in one place and bringing the right kind of compute to it. And that includes everything from Databricks to Synapse to, anything that will also support, Delta, and that includes ADF, right? So, a really, really powerful platform to build on.
That's awesome, James. Thank you. I think the message that we wanted to convey today is exactly as I mentioned in the beginning. We have an overlap and we have the ways that we work really well together, as your slides represented really well in terms of the patterns in the architecture where it makes sense for Synapse to be in the same picture with Databricks. Of course, we are partners, Microsoft and Databricks. We have our journeys together as part of the same architecture.